In this video, I'm going to talk about naming several different types of compounds, including acids, hydrates, and organic compounds. The first one is acids, and acids are things that have an H plus that readily comes off, leaving an anion. So all of the naming for acids is based on the anion name that is left behind when the H plus comes off. So they are based on anion names. And they are separated in two completely different categories. Acids that have oxygen, known as oxoacids, which I'll deal with second, and then acids without an oxygen. The ones without an oxygen, for example, HF, are named with this formula. Hydro, the phrase hydro, plus the anion root name, plus ic, and then as a separate word, acid. So for HF, you write the word hydro, or the partial word hydro. The anion for this is fluoride, and the anion root is fluor. So we put fluor, then ic, and that's all one word, hydrofluoric, and then acid's a second word. Another example is HCl, hydro, except this one's chloric acid, hydrochloric acid. And finally, I'll do HI, which is hydroiodic acid. All right, if the acid has oxygen in it, which lots of them do, it's called an oxoacid, and the naming is a little different. Okay, with the oxoacids, again, the name is based on the anions. First, we're going to look at a case where there are two similar anions. Okay, SO4 2- is an anion, and SO3 2- is an anion. We know SO4 2- as sulfate when it's an anion, and SO3 2- is sulfite. Okay, so notice the only difference between them is the number of O's. So we can kind of say there's a graph, number of O's going up. All right, the one with more O's, the ending will change to ic. And the one with fewer O's will change to OUS. So when you add the H pluses, in this case it'll be 2 to balance the charges, you'll have H2SO4 and H2SO3. You change sulfite to ic, so it becomes sulfuric, and of course it's acid. Then sulfite becomes sulfurous acid. All right, so change the endings. Now let's look at some examples where there are more than 2 in the sequence. Let's look at ClO4-, ClO3-, ClO2-, and ClO-. Okay, this sequence has 4 in its series of the number of O's. Okay, what are the names for these anions? This one is perchlorate. This one is chlorate. Okay, so the ones with the most O's have the 8 ending, just like sulfate. The ones with fewer O's have the ite ending, and to distinguish the one with the fewest, it's hypochlorite. Okay, so you get the ite ending for the fewer O's, the 8 ending for more O's. You also get a prefix for the greatest and the fewest O's. All right, so similarly, those are going to change when they become acids. Okay, let's see what they look like. Go get 1 H plus on each. So the acids are HClO4, HClO3, HClO2, and HClO. The endings will change just like they did for the case of sulfuric and sulfurous acid. The beginnings will be just like the parts I underlined. So this one will be perchloric acid, Okay, the second one's also an ic at the end. Chloric acid. The next one will be an OUS ending. Chlorous acid. And the final one will get that hypochlorous acid. So again, you have the per and the hypo for the greatest and least. You have the ic for the two greater ones, greater O's, the OUS for the ones with fewer. Okay, now I'll give you a few to try. I'm going to ask you to name the acid HNO3 and HNO2, remembering that they come from the anions. NO3, which is nitrate, and NO2, sorry, I forgot the minus, which is nitrite. Okay, the first one should be nitric acid. The second one should be nitrous acid. Similarly, try a sequence of 4. Very much analogous to the previous one. I'll just write the acids. HBrO4. And how about HBrO2? Okay, well, they come from the series, which is very much analogous to the chlorine series. BrO4 minus, BrO3 minus, BrO2 minus, and BrO minus. Okay, so this one and this one are related. This one should be per-bromic acid, and this one would be bromous acid. All right, let's go on to hydrates. Okay, hydrates are simply some compounds that come with waters attached to them. And I'm going to use waters as a plural because often they have more than one. All right, and how do we deal with them as far as naming? First of all, we use a dot in the formula. And then we use the word hydrate in the name. And we show how many waters there are by a prefix. Okay, so this compound has a dot. Okay, there's a dot in the middle. The dot goes between the ionic compound and the number of waters. This ionic compound is magnesium sulfate, so that is certainly part of the name. Magnesium sulfate. And then you use the word hydrate for how many waters there are, and there's 7, so that's hepta. 7 is heptahydrate. And that tells you it's a magnesium sulfate salt with 7 waters on it. Okay, this one would be barium chloride. So you just name the ionic compound, and then you have 2 waters, so you have 2 hydrates, which is dihydrate. You can also have barium chloride without any waters whatsoever, in which case you would simply write that it's barium chloride, or you might also use, to be specific that there's no waters attached, you might say anhydrous, which means without water. Anhydrous barium chloride. All right, we also use a lot of common names for things, okay? Epsom salt, water, ammonia. Those are not systematic names in any way. They're common names. In fact, Epsom salt is magnesium sulfate heptahydrate. So that's the common name for it. We say Epsom salt sometimes. Water, okay, you know the formula for water. H2O, that's a common name. What would you should be able to write what the systematic name is for that. Okay, the system would be that you use dihydrogen monoxide. All right, and ammonia, NH3. I'll leave that one to you to name. All right, and organic compounds. I'm just going to teach you a few simple organic compounds that will often be talked about. These are known as hydrocarbons, which means they have all H's and C's and nothing else. Hydrocarbons means it has hydrogen and carbon. And all types of fuels are hydrocarbons. So we're going to talk about how many carbons they have. Okay, and so the formula will have some number of carbons. The formula for one carbon is CH4, and that is methane, which is clearly used as a fuel. The second one, 2 carbons, C2H6, is ethane. 3 carbons, C3H8, is propane, also a common fuel. 4 carbons, C4H10. You may notice that the number of hydrogens is twice the number of carbons plus 2 for these. Okay, 4 is butane. 5, C5H12 is pentane. 6, C6H14. You should be able to write the rest of the formulas here yourself. That's hexane, a common solvent, but also could be a fuel. C7H16 is heptane. And finally, C8H18 is octane, which is used in gasoline. All right, so those are some simple organic compounds that will be used commonly in general chemistry that you should know.